Greetings and welcome to the Singapore Math Olympiad 2023 Junior Section Round 1 walkthrough, where I will share some of the tips and tricks to tackle this year's paper. Students preparing for the future SMOs are advised to attempt all the questions before looking at this year's solutions so as to strengthen your own problem-solving heuristic. The SMO is organized by the Singapore Mathematical Society and it seeks to nurture mathematical talents in Singapore. The junior section is open to lower sec students with an age limit of 14 years old. It is a 2.5-hour paper with 25 questions in total, and this comprises 5 MCQ questions and 20 open-ended questions. Do remember that calculators are not allowed, and the top scorers will be invited to round 2. Let's begin. In question 1, in a certain company, 1/3 of the employees have a university degree. Half of the degree holders are men, and 40% of the employees who do not have a degree are women. If 102 of the employees are men, how many are women? Pause the video here and give this question a good try. So let's solve problem 1 with the good old primary school style of model method. We know that 1/3 of them are degree holders, 2/3 of them are not, and out of that 1/3, half of it, which is 1/6, are women, 1/6 are male. So let's color women to be pink and men to be the green bar. So if we look at the non-degree holders, out of that 2/3, 40% are women. So that would be 40% of 2/3 is 4/15 are women. So the males account for 60% of the 2/3, which is 2 out of 5. If we add up the two fractions, 1/6 and 2/5, that gives us 17/30 of the entire company are male, which is 102. This will tell us that the total size of the company is 180 people, meaning that the number of women employees would be 180 minus 102, which is 78. And that's our final answer. Question number 2. How many non-congruent triangles with integer side lengths have perimeter 7? Pause the video here and give this question a good try. So in question 2, we are first looking for the unique partitions of 7, and in total there are 4 combinations, and we can just list them out by first forcing the smallest side to be 1. This gives us 3 possibilities. 7 can be 1 plus 1 plus 5, or 1 plus 2 plus 4, or 1 plus 3 plus 3. Next, we will consider that the smallest side to be 2, and there's only one possible combination, 2 plus 2 plus 3. So just by forming an orderly list, we can generate all the possible combinations. But don't forget, we don't just want partitions of 7, we want to make sure that they form triangles. So to be a triangle, the sum of the two smallest sides has to be larger than the longest side. This is the triangle inequality. And you'll see that for 1 plus 1 plus 5, this does not work because 1 plus 1 is not greater than 5, nor is 1 plus 2 greater than 4. So the first two will not form triangles. This checks out for 1 plus 3 plus 3 and 2 plus 2 plus 3. These will all form triangles. So in total, there are 2 possible triangles. Question number 3. The median and mean of 5 distinct numbers, 4, 7, 10, 11, and n, are equal. Find the sum of all possible values of n. Pause the video here and give this question a good try. Since they are all distinct, one of these numbers must be both the mean and the median, and we will consider 3 cases. First, we will take 10 to be both the mean and the median, so the mean works out to be 4 plus 7 plus 10 plus 11 plus n over 5, and this has to be equals to the median of 10. We can calculate n, it would be 18. In case number 2, we consider n to be the mean and the median. So this works out to n equals to 8. And lastly, for the case where 7 is both the mean and the median, we can evaluate n to be 3. So the sum of all possible values will be 18 plus 8 plus 3, which gives us 29. Question number 4. In the following diagram, it shows two semicircles whose diameter lie on the same line. AB is a chord on the larger semicircle that is tangent to the smaller semicircle at the point C, and it is parallel to the diameter of the larger circle. Given that the length of AB is 16 cm, what is the area of the shaded region? Pause the video here and give this question a good try. A nice trick here is to shift the smaller semicircle such that both are now concentric, having the same center. This divides the chord AB in half, so the length of CB is now 8. Let's now label the larger radius big R and the smaller radius small r. Notice that this forms a right-angled triangle, so by Pythagoras' theorem, big R squared minus small r squared equals to 8 squared. Now we want the area of the shaded region, which has not changed after shifting the smaller circle. So the area of the shaded region is equals to half times pi r squared of the big radius minus half pi r squared of the smaller radius. And since we factorize out half pi to get bracket r squared minus r squared inside the bracket, big R squared minus small r squared is just 8 squared. So if we evaluate that, that gives us 32 pi, and that's our final answer. Question 5. The graph of y equals to ax squared plus bx plus c with the maximum point at x equals to -1 is shown below. Which of the following statements must be true? Pause the video here and give this question a good try. Notice that we're given a sad quadratic graph that concaves downwards, so we know that a must be less than 0. By expressing the equation in its vertex form, a bracket x plus 1 whole thing squared plus k, you can expand that vertex form and then compare the coefficients of the x terms. So b is equals to 2a, and since a is negative, b must also be negative. Lastly, for c, we can see it in the graph. It is the y-intercept and it is clearly negative. This tells us that statement 4, the product of a, b, c, must also be negative. Next, we can look at the turning point. When we substitute x equals to -1, this gives us the y value to be a minus b plus c, and based off the picture, it is positive. Therefore, statement 1 must also be true. So the final answer is statement 1 and statement 4. Question 6. The product of the ages of 3 adults is 26,390. Find the sum of their ages. Note that a person is only considered an adult if they are at least 21 years old. Pause the video here and give this question a good try. By prime factorizing 26,390, you'll get 2 times 5 times 7 times 13 times 29, so 5 distinct prime factors. Note that out of the 5 factors, 4 of them are not enough to stand alone to be an adult. Only 29 is old enough, so the other 4 needs to be paired. So the only possible pairing is 2 times 13, that gives 26, 5 times 7, that gives 35. So the sum of all the ages will be 26 plus 35 plus 29, and this gives us a final answer of 90. Question 7. Let n be a positive integer such that n plus 11 is a factor of n squared plus 121. Find the largest possible value of n. Pause the video here and give this question a good try. Well, if n plus 11 is a factor, then it must divide n squared plus 121 without any remainder. So let's perform some long division, but for polynomials. So polynomial long division is a Sec 3 topic, and you can check out my video on polynomial long division for more details. But it's very similar to arithmetic long division, and it goes like this. First, we need to complete the quadratic by inserting the 0n term. Next, we take the leading coefficient, n squared divided by n. This gives us n. So n times n plus 11 is going to give us n squared plus 11n. And we subtract 0n minus 11n gives us negative 11n. And then we bring down the 121. Next, we again divide the leading coefficient, negative 11n. And we divide it by the divisor n. and that's given us negative 11. Then we multiply it by the divisor, that gives us negative 11n minus 121. Then 121 minus negative 121 gives us a remainder of 242. But we said at the start that there should be no remainder. Therefore, n plus 11 must divide 242. So what is that largest factor of 242? That will maximize our n. So the largest divisor of 242 is 242. So n plus 11 equals to 242. So n will be 242 minus 11, which gives us 231. Question 8. Find the largest integer less than or equal to 3 plus root 5 to the power of 3. Pause the video here and give this question a good try. First, we will perform the cubic expansion of a plus b cubed, which will give us a cubed plus 3a squared b plus 3ab squared plus 3b cubed, which is as follows. Next, we're going to use a nifty little trick, which is we're going to add 3 minus root 5 cubed. And if we expand that, it is very similar to our previous expansion, except that now all those surds will cancel away, all those evil surds that we do not want to evaluate. What is left are all integers that we can evaluate, and it will give us 144. But bear in mind, 3 plus root 5 cubed plus 3 minus root 5 cubed is not what we want to find. However, note that 3 minus root 5 is 2 point something, so 3 minus root 5 is less than 1. And when you cube something less than 1, it's still less than 1. That means that 3 plus root 5 cubed is going to be 143 point something, meaning that the integer less than or equal to it will be 143, and that's our final answer. Question 9. The product of a 2-digit number x4 and the 3-digit number 3yz is 7656. Find the value of x plus y plus z. Pause the video here and give this question a good try. First, let's just show you why x cannot be 1. So if x is 1, then the largest 3-digit number starting with 3, which is 399 times 14, is only 5,586. So we cannot reach 7,000 something. You can also use similar arguments of the smallest 3-digit number like 300 times 34 to show you why it can't be, why x cannot be 3 as well. Therefore, x has to be 2. Then it's very simple. You just take 7656 divided by 24 and you'll get 319. So the final answer will just be 2 plus 1 plus 9, and that's 12. Question 10, an Olympiad staple. So if x and y are real numbers such that x plus y equals to 12 and xy equals to 10, find the value of x to the power 4 plus y to the power 4. Pause the video here and give this question a good try. So we'll tackle this using some standard algebraic identities. Firstly, we're going to use x squared plus y squared equals to x plus y whole thing squared minus 2xy. So we sub in x plus y equals to 12, xy equals to 10. Therefore, x squared plus y squared must be 124. And we do the same thing for x to the power 4 plus y to the power 4. It would be equals to x squared plus y squared whole thing squared minus 2 times of xy whole thing squared. Sub in what we have found, so it's just 124 squared minus 2 times 10 squared. So the final answer is 15,176. Question 11. Let a and b be positive integers such that a squared plus 4b squared is less than or equals to 1,105. Find the largest possible value of the product ab. Pause the video here and give this question a good try. Well, for more advanced students, you can employ the AMGM inequality that states that the arithmetic mean of the two terms a squared and 4b squared, which is a squared plus 4b squared over 2, is always greater than or equal to the geometric mean, which is in this case square root of a squared times 4b squared. And we can simplify that to 2ab. Next, we're going to multiply 2 on both sides. This tells us that 4ab is less than or equal to a squared plus 4b squared. which we are told in the question is less than or equal to 1105. Now we can divide by 4 to show that the product AB has a theoretical maximum of 276.25, but that is impossible because A and B are both positive integers. How can the product be a decimal? Well, what's more useful is that AMGM inequality tells us that this maximum only occurs when the two terms are equal. So A squared equals to 4B squared, or in other words, A equals to 2B. Alternatively, for students who do not know the AMGM inequality, you can invent the AMGM inequality on the spot. What you do is that you will subtract 4AB from both sides of the inequality, like so. You will notice that on the left-hand side, it is a perfect square. We can factorize it to A minus 2B squared, and on the right-hand side, we have 1105 minus 4AB. Now, what is the smallest that the right-hand side can possibly be? Square numbers cannot be less than 0. So the largest 4AB can be is 1105. And this gives us back AB to be less than 276.25. And you see that this only occurs when the square is 0, so A equals to 2B. So this is how we invent AMGM inequality under competition conditions. The more important result is that we are going to use A equals to 2B as a guide of where to hunt for our maximum. So we'll sub that back into A squared plus 4B squared, and that will tell us that 8B squared is less than or equals to 1105. Solving that tells us that B is approximately 12. Probably. Well, what we can do is we can test values near that. So let's test B equals to 12. And we'll test A equals to double that, which is 24. A squared plus 4B squared will be 1152. That is, however, too big. So what we will do is we will test B equals to 11, A equals to 24, and that works. A squared plus 4B squared is under 1105. We could also test B equals to 12 and A equals to 23, and this one hits perfectly. A squared plus 4B squared is 1105. But what we should do is compare the products of A times B, and you'll see that 11 times 24 is less than 12 times 23. So the maximum product is going to be 12 times 23, which is 276. Question number 12. Find the value of n such that the following equation holds. Pause the video here and give this question a good try. For this question, we can cross multiply the denominator over, and then we're going to just patiently expand and pray for common terms like these two, consolidate all the like surds, and we're just going to get n equals to 3. Question 13 is quite the unfair question, logarithms for the junior category, but basically it goes like this. The lengths of the sides of a triangle are log 12, log 75, and log n, where n is a positive integer. Find the number of positive values for n. Pause the video here and give this question a good try. We are going to apply the triangle inequality that states that the largest side must be smaller than the sum of the two smaller sides, otherwise the triangle can't be formed. Well, we'll consider two cases. First case, we'll let log n be the largest side, with the possibility of tying with log 75, which forms an isosceles triangle. So log n is greater than or equals to log 75, and it must be smaller than the sum of the two other sides, log 12 plus log 75. So using the product law, we'll get log 900. 900 comes from 12 times 75. So by comparison, n must be between 75 to 900, inclusive of 75. Case 2 will let log 75 be the largest side. So log 75 will be smaller than log n plus log 12. So we can bring the log 12 over, which gives us log n is greater than log 75 minus log 12. And you can use the quotient law to simplify the right-hand side to give log 75 over 12. But by comparison, n will be bigger than 75 over 12 and less than 75. So we can see that n must lie between 6 and 1/4 to 900. So the answer is just the number of positive values that lie between these two integers, which would be 893 possible answers. So the answer is 893. Question 14. Let x be a real number. What's the minimum value of 20x squared plus 10x plus 3 divided by 2x squared plus x plus 1? Pause the video here and give this question a good try. Well, we can use polynomial long division to simplify this algebraic fraction, or we'll just use basic algebra. You can see that the numerator can be expressed as 10 times of the denominator, 2x squared plus x plus 1 minus 7. So we can further simplify this to 10 minus 7 over the same denominator of 2x squared plus x plus 1. And if we want this to be the smallest possible value, then this has to be the largest possible value. So let's do something to the denominator. Let's complete the square. We're going to get 7 over 2 times x plus 1/4 squared plus 7 over 8. So notice that for the entire fraction to be big, then the denominator needs to be small. So what's the smallest possible value that it can take? It would be when the square is 0, so the smallest value is 7 over 8. So 10 minus 7 divided by 7 over 8 will be 10 minus 8. So the smallest possible value is 2. So in the following diagram, ABCD is a square with side 16 cm. E lies on CD such that the length of DE is 4 cm. M and N lie on AD and BC respectively such that the two lines MN and BE are perpendicular to each other, and X is its intersection. So given that MX is equals to 11 cm and BN equals to X cm, what is the value of X? Pause the video here and give this question a good try. First of all, I'm going to extend the lines BE and AD to form this blue triangle, and this blue triangle is similar to this big yellow plus blue triangle. Notice that the two lines DE and AB are parallel, and they have a common white angle there as well. So you can show that by AA property they are similar. So by the ratio of corresponding sides, we can show that the ratio of their base, 16 over 4, is equals to the ratio of their heights, y plus 16 over y. And you solve this, you'll get y equals to 16 over 3. So let's examine this small blue triangle. Let me blow it up first. You can see that this blue triangle has a base of 4, a height of 16 over 3. By Pythagoras theorem, we can work out the hypotenuse to be 15 over 4. And if we scale this blue triangle down, we times 3/4 to all its sides, we're going to get our favorite triangle, the 3, 4, 5 triangle, shown in purple. So this is very useful because you're going to see that all the triangles can be given in ratio of 3, 4, 5. The similar triangles have this ratio. So let's form another triangle. Let's extend the lines MN and BA to form this green triangle. And I'm going to argue that this green triangle is similar to the blue triangle. In fact, all the triangles are just similar. So how we can show this is that the two white angles are equal, because if we add them to the purple angle, they will give us 90 degrees for some triangle. So next, we can compare this green triangle to the 3, 4, 5 triangle. We will know that the sides can be expressed as 4a and 5a, some scale factor of the 4, 5 sides. Now we will compare it to this bigger orange triangle, which is also similar because of AA. They have the two angles in common. So what we can do is use the ratio of corresponding sides. Solve for A will be equals to 1. Now let's look at this red triangle. We know that this side is now 4 plus 16, so it's 20, and if we compare it to the 3, 4, 5 triangle, it is the purple triangle scaled by 5, meaning that X would be the side 3 scaled by 5, so times 5 as well. So the answer is going to be 15. Question 16. Find the smallest positive integer k such that every subset of the set 1, 2, 3, all the way to 2023 with exactly k integers contains 3 integers a, b, c with the property such that if a is less than b less than c, a times b would be equals to c. Pause the video here and give this question a good try. So this is a pigeonhole principle question, and the keyword is every, and what we are really looking for is the largest subset such that no 3 integers have the property of a times b equals to c. So what we'll consider is the subset 45, 46 all the way to 2023. Notice that 45 times 46, the two smallest numbers multiplied together, is already 2070, which is larger than 2023. Therefore, no two numbers inside here can have the property where their product lies inside the subset. And if we were to go a little bit bigger, 44 to 2023, notice that 44 times 45 gives us 1980, which lies inside the subset. So 44 would not work. And how did I find this number 44, 45? What I did was I square rooted 2023. It gives about 44 point something because 2025 is a perfect square of 45. So don't forget that we also need to include the number 1, because 1 times anything gives that same thing back. Like 1 times b will give us b, and you will not be able to form a product of 1 times b equals to c because b and c needs to be distinct. So the largest subset would be this subset 1, 44 all the way to 2023, and there's 1980 possible integers where no 3 integers have that property. So the answer would be 1981, because if we just insert one more number in, then every subset must have 3 integers that fulfill the a, b equals to c. Question 17. The difference between the LCM and HCF of a positive integer n and 18 is 627. Find the value of n. Pause the video here and give this question a good try. So we can prime factorize 18 to be 2 times 3 squared, and we can also prime factorize the difference 627 to be 3 times 11 times 19. Note the property that the highest common factor must divide the lowest common multiple. Therefore, the highest common factor must also divide the LCM minus the HCF, the difference. This tells us that the highest common factor must be 3, because if we look at the LCM minus HCF, the factors are 3, 11, and 19. The only common factor between 18 and 3, 11, 19 is 3. So 3 is the only number that can divide 18 as well as the difference. This tells us that the LCM must be 630. With that, we can use the property that the two numbers, n and 18, their product is also the product of the HCF times the LCM. So n will be equals to 3 times 630 divided by 18, and that gives us 105. Question 18. The sum of all the interior angles except one of a convex polygon is 2023 degrees. What is the number of sides of this polygon? Note that a polygon is convex if every interior angle is between 0 and 180 degrees. So pause the video here and give this question a good try. So the sum of angles in a polygon is the number of sides minus 2 times 180 degrees, and that's equals to 2023 degrees plus our unknown angle theta, meaning that 2023 degrees plus theta must be divisible by 180 degrees. So let's express 2023 as 180 times 11. So with 11 sets of 180 degrees plus a leftover, a remainder of 43 degrees plus our theta. That must mean that 43 degrees plus theta is also 180 degrees, meaning that the total number of 180 degrees is 12 sets of them. So n minus 2 equals to 12, n would be 14. Question 19. If the square root of 19 minus 8 root 3 is the root of the equation x squared minus ax plus b equals to 0, where a and b are rational numbers, Find the value of a plus b. Pause the video here and give this question a good try. So there is a trick to simplify the square root of 19 minus 8 root 3. And what we can do is we can express 19 as 4 squared plus root 3 squared. Then we can change 8 to 2 times 4, because this will give us the form of x squared plus y squared minus 2xy, which makes it a perfect square. So we can factorize the inside of the cert to be 4 minus root 3 whole thing square. And the square will cancel out the square root. Just make sure that we get a positive result of 4 minus root 3 and not root 3 minus 4, because when we square root something, it has to be a positive output. So if we have that, x is equals to 4 minus root 3, then x minus 4 equals to root 3. We square both sides. We'll get x squared minus 8x plus 16 equals to 3. Subtract 3 on both sides. This tells us that a equals to 8, b equals to 13. So a plus b must be 21. Question 20. Given that x and y are positive integers, find the smallest positive integer n such that x squared plus y cubed equals to n to the power of 4. Pause the video here and give this question a good try. So to hunt for it, we will just let y cubed equals to n to the power of 4 minus x squared, which is a difference of squares, so we can factorize it as n squared plus x and n squared minus x. Now what we're going to do is just pray and hope that n squared plus x equals to y squared and n squared minus x equals to y, and hopefully this will just work out. Now if we add those two terms y squared and y together, we will get n squared plus n squared minus x. The x will cancel out. So you can see that n squared equals to y times y plus 1 over 2. So what we are looking for is a triangular number that is also a square number. So what I will do is list out all the triangular numbers. Now I don't have to start from 1 times 2 over 2, because that will give me 1. While 1 is a triangular number, you'll see that 0 squared plus 1 cubed equals to 1 to the power of 4. Of course that would work, but then x would end up to be 0. And that's not possible because x has to be a positive integer. So smallest triangular number will start from 3. That's not a square number, so nope. 6 not a square number, 10 not a square number, 15 not a square number, 21, 28, 36, and that works. So let's just sub it in and check whether it really works. You'll see that n squared is 36, then n must be 6. And we'll see that the y is 8. And we can evaluate the x. That will be n squared 36 minus away the 8. So we'll get 28 squared. And indeed, if you calculate, 28 squared plus 8 cubed equals to 6 to the power of 4. So our final answer is 6. So in the following diagram, we're given that AB is parallel to DC, AB is 6 cm, AD is 17 cm, DC is 10 cm, and the angle DAB is 90 degrees. E lies on AD such that BE is perpendicular to EC. Given that the triangle BEC has an area of k cm squared, what is the largest possible value of k? Pause the video here and give this question a good try. So observe that this red triangle is similar to this yellow triangle, and we can prove this because of AA. You can see that this blue angle and this green angle adds up to 90 degrees, and this blue and this green angle also adds up to 90 degrees. So by the AA property, you can show that these two triangles are similar. Next, we can also break up the 17 into x and 17 minus x. So we'll let the length of AE be x and ED be 17 minus x. So since they are similar, we can use the ratio of corresponding sides, simplify it to get a quadratic equation, and solve the quadratic equation and get x equals to 5 or 12. But that's not what we want. We want the area. So the area is equals to the parallelogram minus two triangles. So area of parallelogram is the height 17 times the sum of parallel sides, 6 plus 10, divided by 2. subtract the red area, which is 3x, and subtract the yellow area, which is 5 times 17 minus x. Simplify all that, we will get 51 plus 2x. We have two possible values for x, 5 or 12, but we want the largest possible value for k, so we'll let x equals to 12. So 51 plus 2 times 12 gives us a final area of 75. Question 22. The angle between the hour hand and the minute hand of a clock is denoted by theta degrees, where theta lies between 0 and 180. If the clock shows 3:y, which is 3 o'clock and y minutes, and theta is 175, find the value of y. We are also given the constraint that y needs to be a positive integer. Otherwise, we can't shade it in the answer. So pause the video here and give this question a good try. Now let's figure out where the hour hand is first. So it lies somewhere between 3 o'clock and 4 o'clock. So let's just mark it here with a red angle that denotes the angle difference from 3 o'clock to where it actually is. Note that in 60 minutes, the hour hand only travels 30 degrees. So in y minute, it travels 30 degrees over 60 times y. And you can simplify that to y degrees over 2. Now let's see how far the minute hand has traveled from the 3 o'clock. So it's from the 12 o'clock. You can see it will travel to this green line, and it will have traveled this yellow angle. So how big is this yellow angle? So let's go by the rate that it travels. In 60 minutes, the minute hand goes one complete circle of 360 degrees. So in 1 minute, it would have traveled 6 degrees. So in y minutes, it would have traveled 6y degrees. So this yellow angle is 6y degrees. Note that we'll also have the difference between the green line and the blue line. The angle difference is 175 degrees given in the question. So we can say that 6y degrees, the yellow angle, equals to a right angle, 90 degrees, plus the red angle, plus the blue angle. So we have an equation in y, and we can happily solve that y equation to find the value of y, and our job is done. We get y equals to 48 and 2 over 11. Wait a minute, that's not an integer. We have screwed up. So we need to rewind time and see what we have done wrongly. We have assumed that the angle 175 degrees is taken clockwise when it could have been taken anti-clockwise as well. So in this case, 6y degrees is equals to 90 degrees plus y degrees over 2 plus 185 degrees, which is just an extra 10 degrees from the 175. So we can solve this and get y equals to 50, and that is the correct answer. Question 23. The diagram shows a river with two bridges at A and B that are 2 kilometers apart, and the water flows from west to east at a constant speed. A man is rowing a boat upstream. He drops the bottle at A but notices it only at C after rowing for 20 minutes upstream. He turns back and rows downstream and picks his bottle at B. We can assume that his boat has a constant speed. Find the speed of the current in kilometers per hour. Pause the video here and give this question a good try. So firstly, I'm going to let the speed of the current downwards be v. Now, we can work out how far the bottle has traveled by taking the speed times the total time. So this red journey downstream would be the velocity v times the total time t, and we know that is equals to 2 kilometers. Next, we're going to see how far the man rowed upstream before turning back. So from A to C, he traveled for a time of 20 minutes. So that's 1/3 of an hour. And his speed, so let the speed of the boat be b. Notice that if he's traveling upstream, his speed is b minus the current v. So the total distance will be 1/3 the time times the velocity b minus v. Then he turned around and he traveled downstream. So his new speed will be b plus v. So the speed of the boat b plus the current dragging him down at a speed of v. And we'll multiply it by the total time t minus the time he spent traveling upstream, which is 1/3 of an hour. So you can see that this is equals to the sum of the AC plus AB. So it's, we can also expand this entire thing, and we can cancel out the common terms. This will tell us that B times T minus 1/3 B is equals to 1/3 B. The B's all cancel out, and we'll just get T equals to 2/3. That means his total time that he traveled is 40 minutes. We can sub that back into VT equals to 2. This works out V will be 3, and that's our final answer. Question 24. Four positive integers x, y, z, and w satisfies the following equations. Now, given that x, y, z, w is prime factorized to be 2 to the power 7 times 3 squared times 5 times 7, we want to find the sum of the four integers. So pause the video here and give this question a good try. So we can employ a nice little trick by adding 1 to both sides so that the left-hand side can be factorized. For example, the first equation will give us x plus 1 times y plus 1 equals to 105, and we can prime factorize 105 to be 3 times 5 times 7. So we'll do the same thing for the second equation and the third equation. If you take the first equation and multiply it to the third equation and divide it by the second equation, you can also generate a fourth equation of x plus 1 times w plus 1 equals to 3 times 5 cubed. Now you just have to assign the correct prime numbers to the correct factors. So this is just a game of trial and error. You will work out that w plus 1 equals to 5 squared, z plus 1 is 3 times 7, y plus 1 is 7, and x plus 1 is 3 times 5. You also want it to be 1 bigger than a nice composite number that can be factorized into prime factors of 2, 3, 5, and 7. So that should guide your guessing. Now, with that, we can solve for w, z, y, and x. Then, as a final check, you should check that if you multiply them all together, that we have 7 factors of 2, 2 factors of 3, 1 factor of 5, and 1 factor of 7, and it all checks out. So the sum of all these integers will be 64, and that's our final answer. Last question, question 25. In the following diagram, ABC is a triangle. Points E, D, and F lie on side BC and divide that side into 4 equal parts. M is the midpoint of AB and CM, and it intersects the line segments in a ratio of x to y to z to u, and these are all positive integers. Find the least possible value of x plus y plus z plus u. Pause the video here and give this question a good try. I'm going to just show you a brute force method, which I do not recommend, but if you are desperate, you can use coordinate geometry to solve this. You can let point A be -2, 0, B be 2, 0, and M be the origin. Then you can construct the triangle. Because this triangle can be any triangle, it will work for all triangles. We'll set C to be at 2, 4. Then your points E will be at 2, 3, and you can work out the equation of the line AE. Same for the line AD as well as the line AF. Lastly, we need to intersect it by the line CM, and we already know that that is y equals to 2x. So we have many equations. We can do a lot of simultaneous to find these 3 points and find the distance of M to each of these red points and work out the ratios. But instead of coordinate geometry, I'm going to use a very general method of tackling this kind of question, and that's using vectors. So I'm going to let vector of AM be A and MB also be A. BF, F to D, D to E, and E to C will all be vector B. So if you're not familiar with vectors, you can think of vectors as like a special kind of step. So step A and step B are 2 non-parallel steps. And basically, if I want to get from anywhere to any other place, I can use some unique combination of steps A and steps B. So in particular, if I want to get from M to C, I can take a step A followed by 4 steps of B. So we can say that M to C is equals to A plus 4B. Similarly, I can also say that this red vector A to F is equals to 2 steps of A, 2A, plus 1 step of B. So it's 2A plus B. And the place that I really want to go is I want to get to Z. So Z is shown by this yellow point. I want to get from A to Z. So how do I get from A to Z? So one way is I can travel some fraction of A to F, and that fraction is this unknown P1. So A to Z is some fraction P1 times 2A plus B. That's one way to get to Z from A. Alternatively, I can also walk from A to M first, which is A, plus some fraction of M to Z, which is Q1. And notice that Q1 is what we want to find later. And this Q1 of M to C is A plus 4B. So I'm taking this unknown fraction Q1 of the vector, of the purple vector M to C. So we have said that this A to Z is a unique combination of A's and B's, meaning that if I expand the left-hand side and the right-hand side, I can compare the coefficients of the vector A's as well as the coefficient of vectors B's separately. This will give me two equations with two unknowns. So 2p subscript 1 equals to 1 plus q1 is the first equation. P1 is also equals to 4q1. I will sub away the P1 because I don't care about that ratio. I only care about Q1, and Q1 is 1 over 7. So bear in mind, what does this mean? It means that 1 over 7, the physical representation, is that the distance from M to Z is 1/7 of the distance from M to C. So already we have one of the fractions out. So now we're going to repeat this again. So the next vector I'm interested in is A to D. So I've shifted the red vector to A to D. And that is formed by 2 steps of A followed by 2 steps of B. So A to D is 2A plus 2B. And the place I really want to go is Y, that lies along A to D. So it is some fraction of A to D. So let's call it P2. So P2 times 2A plus 2B is equals to 1 step A that gets us from A to M plus M to Y. So M to Y is some fraction of M to C. So we'll call that fraction Q2. So it'll be A plus Q2 times of A plus 4B. Again, I expand and I compare the coefficients of the vectors A and B separately. I'll get two equations. Sub away the P2, find Q2. Q2 be 1/3. This tells me that the distance MY is 1/3 of the distance MC. So let's do this one more time. So now I have shifted the red vector to A to E. So A to E, and the place I want to get to is Z. So A to E is 2 steps of A plus 3 steps of B. And if I want to get to Z, I'm going to take some fraction of A to E. So P3 times of A to E, which is 2A plus 3B. And it's equals to A to M, which is A, plus some unknown fraction of M to C. So A plus Q3 of A plus 4B. Expand, compare the coefficients of A and B separately, get two equations, solve for Q3. Q3 will be 3 over 5, meaning that the distance from M to Z is 3/5 of the total distance of M to C. So with that, I can work out the ratios of each individual pieces. So X will be 2/5, 1 minus 3/5. Y will be 3/5 minus away 1/3. Z will be 1/3 minus 1/7, and U will be 1 over 7. Of course, these are all horrible fractions. We can simplify them by multiplying by 105 throughout. This will give me integer ratios of 42 to 28 to 20 to 15. And if I add them all up, my answer will be 105. And that's the final answer. So with that, we've come to the end of the walkthrough for the junior section of the SMO 2023. If you have any questions on any of the solutions, you can post it in the comment section below, or if you have better methods to solve any of these questions. But thank you for your kind attention throughout this entire video if you made it to the end, and have a great day of learning.